All right, so for this problem, we're going to figure out any possible points of inflection on this function and then talk about the concavity of the function. So talk about where it would be concave up, concave down, and so forth. So for that, we need to calculate the second derivative. So let's go ahead, let's find the derivative first. So f prime of x, the derivative of the secant function is the secant of x, tangent of x function. So we have the secant of x minus pi over 2 times the tangent of x minus pi over 2. Now we take the derivative again. And remember, use chain rule, or not use chain rule, use product rule. Remember, you have this first be like one function. So take the derivative of this, multiply by this, plus this times the derivative of the second one. So first take the derivative of this, and that will just be secant of x minus pi over 2 times the tangent of x minus pi over 2. We multiply by the second function as is, times the tangent of x minus pi over 2. And then we add this to this function times the derivative of this. So we add this to secant of x minus pi over 2 multiplied by the derivative of the tangent of x minus pi over 2. So the derivative of the tangent function is just secant squared function. So this will be multiplied by the secant squared of x minus pi over 2. And so let's try to clean this up to make it easier to work with. So we have a secant, we can in each group, and we have a tangent squared here. So what we got is the second derivative is the secant of x minus pi over 2 times the tangent squared of x minus pi over 2 plus the secant cubed of x minus pi over 2. All right, now we want to find any possible values where the second derivative is equal to 0 or where it's undefined. So f double prime of x is undefined for, so when we're looking at this interval, we only care about where it's undefined on this interval because it's a trig function especially, otherwise it'd be very cumbersome, be a lot of work. So we need to know our trig. We need to know where is the secant function undefined and where is the tangent function undefined. So I guess let me do a little sidetrack here in case you're a little refresher. In general, the secant function, the secant of x is equal to 1 over the cosine of x. So it's undefined when the cosine of x equals 0. And you should know that the cosine of x is equal to 0 when x equals pi over 2 or negative pi over 2, so positive negative pi over 2, or positive negative 3 pi over 2, or positive negative 5 pi over 2, and so forth. We only care about the ones in here, so we only need to worry about the positive values. But also, it isn't this simple because we're taking the secant of x minus pi over 2. So the secant of x minus pi over 2 is equal to 1 over the cosine of x minus pi over 2. So in other words, we want to find where the cosine of x minus pi over 2 equals 0. Because that's, basically 1 over 0. So we want to set this input in here. We want to set the x minus pi over 2 equal to these values. So we want to set it equal to positive pi over 2, positive 3 pi over 2, positive 5 pi over 2, and so forth. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so forth until we get to 4 pi over 2. So that'll be, we'll stop, that's 3.5. So then we don't need to go any further. We only need to go to 4 pi. Now, we just solve this for x. So just add x, or so it's add, add pi over 2 to both sides. And remember, this is just a pattern. It's not, a literal equation, but just to give you the idea. So it's going to be undefined when x is equal to pi over 2 plus pi over 2, or when x equals pi, or add half a pi to 3 pi over 2, that'll be 2 pi. Add half a pi to 5 pi over 2, that'll be 3 pi. And it's undefined for 4 pi. So it's undefined for these values. Undefined. Now, coincidentally, we also have to, always look at where the original function is undefined. And it's, on this interval, it's also undefined for these same things, because we're just doing x minus pi over 2 equals, 0 again. And that's going to be these values. Oh, no, not equal to 0, but x minus pi over 2 is equal to these values. So again, it's still undefined for those same values. X equals pi, 2 pi, 3 pi, 4 pi. Now, the additional part, you got to look where the tangent of x pi over 2 is undefined. Like, where is the tangent of x pi over tangent of x? Where is the tangent of x minus pi over 2 also undefined? Now, let's remember that the tangent of x is equal to the sine of x over the cosine of x. So think of this as, being equal to the sine of x minus pi over 2 over the cosine of x minus pi over 2. So again, it's undefined when this equals 0. When the cosine of x minus pi over 2 equals 0. Luckily, it's the same thing over here. This happens to be the same thing that we got here. So it's the same, it's going to be the same x value. So we don't have to worry about finding any other undefined values. So we look at x equals pi, 2 pi, 3 pi over 4 pi. Now the other part, the fun's not over yet. We have to look, where is the second derivative equal to 0? F double prime of x equals 0 for, now let's think carefully. So we have to find any possible values that will make this equation equal to 0. So let's make this a little easier to work with. So let's factor out the secant of x, or secant of x minus pi over 2. But there's multiple ways to do it. So let's have f double prime of x. Let's make that 0. So 0 is equal to this. So let's factor out secant of x minus pi over 2 times tangent squared of x minus pi over 2 plus secant squared of x minus pi over 2. I hate squeezing my writing really small, but there you go. Now, you can, do a couple things. You could, you solve this for 0 by, dividing both sides by this, or dividing both sides by this. You essentially, are going to get rid of this. You want to see, is the secant of x minus pi over 2 going to be 0? Like, is this going to be 0? Where is this going to be 0? And or where is this going to be 0? So let's look at it that way. So like, let me move this. Let me actually go over here. So we want to find, like, where is the secant of x minus pi over 2 equal to 0? And when is this in here equal to 0? When is tangent squared of x minus pi over 2 plus the secant square root of x minus pi over 2 equal to 0. Because if either of these equals 0, the whole product will be 0, so the whole thing will be 0. So you want to find, let me put that in, like this in like purple. So 0 times anything is 0, and 0 times anything is 0. So let's look at this one first. Now, remember the secant of x is equal to 1 over the cosine of x. So there's no way for this to be 0 because this is just 1 over the cosine of x minus pi over 2. So this can't be 0 because 1 over anything is not going to be 0. So there's no zeros here, so you don't got to worry about that. So we're good there. Now let's see, where could this be 0? Now, you essentially want to see where would these be opposites. You could do you can translate these into cosine and sine, or would leave it like this. But let's let me think of a better one. Let me break these into sine and cosine because that'll probably be the easiest to recognize. So let's look at it like this. Let's remember this is the tangent function is equal to the sine function over the cosine function. So you basically have the sine squared of x minus pi over 2 over the cosine squared of x minus pi over 2 plus 1 over the cosine squared of x minus pi over 2, that whole thing being equal to 0. Now, we can just combine the top, or we can combine these because we have the same denominator here. So then this will just be the sine squared of x minus pi over 2 plus 1 over the cosine squared of x minus pi over 2 being equal to 0. Now here's the thing, if you think logically, the only way this could work is if sine squared of x minus pi over 2 equals -1, because -1 plus 1 have to equal 0. So that means sine squared of x minus pi over 2 has to equal -1. But you won't have a solution here because if you're squaring a function, if you square a positive number, it's gonna be positive. You square a negative number, it's gonna be negative. So there's no possible answer here. Nothing will work. So there's no zeros. So there's no zeros at all for the second derivative of x. There's for f double prime of x. So yes, you're like, oh, what was the point of all that? The point of all that was to find no zeros. It wasn't a waste of time because you wouldn't have known it unless you checked. But I really like these problems. It's very satisfying. But this is really a good test of your trigonometry. But make sure you don't lose track of the concept here. So we found no zeros for the second derivative, but we found undefined values. So we're gonna now test intervals broken up at pi, 2 pi, 3 pi, and 4 pi. And we're gonna break this interval 0 to 4 pi at these points. So I usually like to make a table. So I like to make a table where it's like my interval is in the top row. And I go from 0 to pi, and then pi to 2 pi, and then 2 pi to 3 pi, and then 3 pi to 4 pi. And then I want to see what the sign of the second derivative is in those intervals. And then I can figure out what the concavity is. So I pick any value in here and evaluate the second derivative. So I can pick, let's just pick some. Let's just pick x is pi over 2. Here I'll pick x is 3 pi over 2. X is 5 pi over 2. And then x is 7 pi over 2. So I just plug these values into my second derivative function. So I plug it into here and see what's going on. Use the simplest one, I guess, to work with, to see what's going on. Let's go ahead. Let's evaluate that. So let's go f. Put some work here. F double prime of pi over 2. F double prime of 3 pi over 2. F double prime of 5 pi over 2. And F double prime of 7 pi over 2. And let's work with this one. It's probably easier to plug in values. So if I plug in, that's not going to work with pi over 2. Hold up. Actually, no, yeah, of course it'll work. Right? I have a little point part. It'll just be 0. So if I plug in pi over 2, I'll have the secant of 0 times the tangent squared of 0 plus the secant squared of 0. Secant of 0 multiplied by the tangent squared of 0 plus the secant squared of 0. Tangent of 0 will be 1 over the cosine of 0, so this will be 1 times the tangent squared of 0, sine of 0 over the cosine of 0, so that'll be the 0, and then I'll get a positive number. I get 1, a positive number, so again, I just put positive. And I'm gonna power through these last 3 because that's not important. So I'll show the work, but let me just save some time here. All right, so here's my scratch work. So I found that in the first interval we get a positive, which I went over. And the next one I got negative because I got -1. And in this interval I got positive again. And then on the last one I got negative. So basically it's going to be concave up in that from 0 to pi over 2, concave down from 2 pi to 2 pi over pi 2 pi, concave up from 2 pi to 3 pi, and then concave down on that last region. And there are no points of inflection, so no inflection points. Now you're like, why aren't there any inflection points? Because it changes from concave up to concave down. It's because these are undefined values. It's undefined at pi, 2 pi, 3 pi, so it doesn't connect. So the graph is essentially doing this. It kind of looks just like that. I have like a little sketch, not drawn to scale, but I have basically I have an asymptote, and on one side the graph is doing this, the graph is going like that, and the other side is going downward. Again, that's not what it looks like, but I'm just saying that's what's going on. Upward on the left, downward on the right. And yeah, that was a good problem, but doing these ones really solidify and make you good at this stuff because trig isn't a pop-up. But yeah, there you go. Hope that helps.